next is the molecular orbital theory. The molecular orbital theory, which talks about the formation of the molecule. Now, we know that the atoms combine together and they form the molecules. But during that combination, when the atoms combine, actually the atomic orbitals combine. And when the atomic orbitals combine, they get converted into a molecular orbital. So here we are going to learn about the properties of these molecular orbital, how they form and how the electrons are filled in a molecular orbital. So atomic orbit, let's see some points of the molecular orbital theory, that is the postulates of molecular orbital theory. The molecular orbital theory, which says that, this theory was given by the Hertz and the Mulliken, and this theory states that like an atom, as in case of atoms, we have energy levels where the electrons are present, that is called as atomic orbitals. In the same way, in a molecule also there is some energy levels, and here we called it as a molecular orbital. As in case of atoms, the electrons are present in an atomic orbital, that is s, p, d and f. Similarly, here in a molecule also the electrons are present in a molecular orbital. How the molecular orbital is formed? Then rule says that, or the theory says that when atomic orbitals combine together, a molecular orbitals are formed. For example, suppose if these two are the atomic orbital. So according to this theory, when these two atomic orbitals combine, they form a molecular orbital. The electrons were first present in this atomic orbital, which moves to the molecular orbital once the molecular orbital is formed. Now, here the atomic orbitals which are combining, they should have approximately same symmetry and the same energy or the comparable energy, then only these two will combine. That is, if this is s orbital, this should be s. If it is a p orbital, this should be, if it is px, then it should be px. If it is py, then py. Okay, so here the two orbitals combine and they form, and then how many molecular orbitals will form if the two atomic orbitals are combining, or during the combination, how many molecular orbital will form? Then the rule says, or molecular orbital theory says, that the number of molecular orbital formed totally depends upon the number of atomic orbitals which are combining. That means if two atomic orbitals are combining, then ultimately two molecular orbitals will form. So here the two atomic orbitals are combining. So according to the rule, two molecular orbital will form, out of which one will have a lower energy and one will have a higher energy. That is like this. One will have a lower energy and one will have a higher energy. The one will have lower energy, that is this. This is called bonding molecular orbital. Bonding molecular orbital. And the one having a higher energy level will called as anti-bonding molecular orbital. So the energy of the molecular orbital which is formed, one is having the energy lower than the atomic orbital energy, and the energy of the other one is the higher than this. This is the energy of the atomic orbital which are combining together. Now suppose if there is a 4 atomic orbitals are combining, then the 4 molecular orbitals will form, out of which 50% will be bonding and the 50% will be anti-bonding. That is, out of 4, 2 will be the bonding molecular orbital and the 2 will be anti-bonding molecular orbitals. Since the molecular or bonding molecular orbital is having a lower energy, that's why it will be a more stable compared to the anti-bonding molecular orbital which is having higher energy. So this is lower energy, will have low and more stable. This is a higher energy, will have more energy. Higher energy, that means less stable. Now in case of atomic orbital which is a part of an atom, and each atom contain only one nucleus. That's why whatever the electrons are present in an atomic orbital, they are influenced by a single nucleus. While in the case of molecular orbital, the molecular orbital which is formed by the combination, or the molecule which is formed by the combination of 2 or more atoms. So the molecular orbital's electron is influenced by 2 or more nucleus. So here I can say these atomic orbitals are influenced by a single nucleus, that's why they are monocentric. While the molecular orbitals are considered as a polycentric because they are influenced by 2 or more nucleus. Now, as the electrons filling takes place in case of atomic orbital, similarly the same way the electron filling takes place in a molecular orbital. Initially the electrons were present in an atomic orbital, but when this atomic orbital get converted into molecular orbital, then electrons get transferred to this molecular orbital, and when the electron transferred, the filling of the electron in a molecular orbital is exactly like the electrons which are transferred to the atomic orbital. Means what rules we follow for the electron filling? In this case, we follow the same rule like Aufbau principle, Hertz rule, Pauli's exclusion principle. The same rules we follow here also. Here also we says that the electron first fill the lower energy level and then it fills to the higher energy level. So this is about the molecular orbital theory. Now, here the after that molecular orbital theory, here I says that two atomic orbitals are combining together and they are forming a two molecular orbitals. Now, how to know means how these atomic orbitals are combining to form a molecular orbitals. It is for explaining this combination we have a various theories, out of which the one theory is there is a one theory which is called as linear combination of atomic orbital. Linear combination of atomic orbitals. Which is known as LCAO rule. Linear combination of atomic orbital. According to this linear combination of atomic orbital, the atomic orbital which are combining, they undergoes linear combination, and so that after that linear combination, that means these atomic orbitals undergoes addition and subtraction, and so that they form a bonding molecular orbital and anti-bonding molecular orbital. The atomic orbital here I am saying they undergo subtraction and addition. So actually the addition and subtraction carried out in the wave function of these atomic orbital, the wave function which is represented by the symbol psi. For example, suppose there is a two atoms A and B are combining and they form a molecule. So during the formation of a molecule, the atomic orbital of A and the atomic orbital of B will combine. So when I'm talking that how the molecular orbital or how the bonding or how anti-bonding is forming, then linear combination of atomic orbital represent this combination in the addition or subtraction form of the wave function. So here A, this is the wave function of this atom A is psi A, and the wave function of this is psi B, capital A and capital B. Either these wave functions undergoes addition or they undergoes subtraction. According to linear combination of atomic orbital, when they undergoes addition, the attraction takes place, and attraction takes place so that the molecular orbital which form is bonding with the lower energy level. But when the atomic orbitals undergo subtraction, so here there is a repulsion takes place and the energy goes on rising, that is a molecular orbital which form is called as anti-bonding molecular orbital. Now let's see how it forms. Here we are talking about the wave function, that means somewhere I'm related the concept with the waves. So let's see how this bonding molecular orbital or anti-bonding molecular orbitals are forming. So suppose here in this case we have a wave. This is for atom A. This is of atom B. Plus, minus, plus, minus. This plus minus doesn't represent a charge, it only this plus minus here represent the crest and trough. Plus means toward the positive side, positive amplitude, negative minus means toward the negative side. So once I use a plus, it means it represent the crest, and minus means it represent trough. So when the two atoms comes closer to each other, there is a two types of overlapping can occurs. Either the crest and the trough, means the crest of the atom A will overlap with the crest of this, and the trough of this will overlap with the trough of B. And when the crest and trough overlapping is taking place, then I can say the atomic orbital which will be formed will called as a bonding molecular orbital. But if the crest of one is overlapping with the trough of other one, then in that case the repulsion will take place, and ultimately I will get the anti-bonding molecular orbital. So when crest or trough overlapping is taking place, bonding, but when the crest when the crest of one wave and the trough of the other wave is overlapping, then it is called as anti-bonding, because the repulsion occurs in that case. And repulsion occurs means the energy goes on increasing. Now in the case of this, here I can say, suppose, now let's see which type of molecular orbitals are forming. Here in the syllabus actually we are talking about the molecules whose atomic number is, whose atomic number, that is the total number of electron in a molecule, is going to be 20 or less than 20. And if the molecules, or here I can say I'm talking about the molecule whose in which when we add the number of total electron, then it is going to be 20 or less than 20. That is, I can say that each atom is having max to max 10 electron. And if each atom is having max to max 10 electron, that means there will be a two orbitals will take part, two different types of atomic orbital. One will be s atomic orbital and the second will be p atomic orbital. From s it will be, there is only one s orbital, but in case of p there is a three different types of orbital, that is px, py and pz. Now let's see how these orbitals combine and what molecular orbitals we get after the combination. So let s orbital of the atom A combines with s orbital of the atom B. So two orbitals are combining, two possibilities will be there. The first one, psi A plus psi B, that is the atomic orbitals are undergoing addition, and here the second is A minus B, that is the subtraction is taking place. The subtraction, if the addition is taking place, that means it is going to be a bonding, and if it is a subtraction, then it will be anti-bonding and the energy will be more. So this is psi A plus psi B, and this is a psi A minus psi B. When the attraction occurs, then during the attraction both the atoms comes closer, that means they overlap with each other and we get this one, a single molecule. This is a molecular orbital, bonding molecular orbital. And here if they are not combining, that is subtraction, then there is no combination and these molecular orbital move away from each other. No combination. If the molecular atomic orbital combine, that is addition is taking place, the molecular orbital which is formed is called bonding molecular orbital. And bonding molecular orbital, as well as we have a one more molecular orbitals are of two more type. The one is called in terms of energy, I said there are two types, that is a bonding and anti-bonding. In terms of orientation, how the molecular orbitals has been formed, on that basis we have two types of molecular orbital. One is called as a sigma and the second is called as pi. Sigma molecular orbitals are those molecular orbitals in which the atomic orbitals are overlapping on the axis, means the combining on axis. But if the same atomic orbitals are overlapping laterally, then it is called as a pi molecular orbital. Now in this case, since the orbitals are s orbitals, here we have s orbitals. So s orbital always overlap on axis, so it is going to be a sigma s orbital, that is sigma bonding molecular orbital. Here overlapping is not taking place, that's why it is anti-bonding, that is sigma. Anti-bonding is represented by the asterisk or star we write here, and then s because it is formed from the s orbital. So once asterisk or star is there, that means it is a anti-bonding molecular orbital. So this is about the s orbital. If two s orbital is combining, then what happens? Now about the p orbital. Now in case of p orbital, we have three possibilities. Means in p we have three orbitals, that is px, py and pz. Px, py and pz. The shape is something like this. Okay. Here I said you can call this as a x-axis, this as a y, this is z, or this x, this y, this z. But here in the case of molecular orbital theory, when we are studying, then molecular orbital theory says that the internuclear axis should be the z-axis. Internuclear axis, that is, this is the first and the second will come from here, that is between the nucleus. So you have to consider this as a z, and it is an internuclear axis, means if the overlapping is taking place on the axis, then it will be from z side, and then it will be a y, and then this is x. And since z is considered as an internuclear axis, so whenever the z orbital, that is pz orbital, will form a bond, that bond is always going to be a sigma. And if the two orbitals are overlapping like this, and if this bond is a sigma, then ultimately these two bonds are going to be a lateral overlapping. That means px and py, they form pi bond. That means their molecular orbital is pi molecular orbital, while the pz molecular orbital is going to be a sigma molecular orbital. Now if this is plus plus, here repulsion, so this and we have two positive charges. Okay. Now, in the case of, let's talk about the pz. What happens when the two pz orbitals overlap, and then we'll see for px and py also. So pz, again, if two pz orbitals are overlapping, then again two possibilities will be there. That is the same subtraction and the addition. If addition is taking place, then bonding molecular orbital will form with the lower energy, and if the subtraction is taking place, then anti-bonding will overlap. So in the addition, what will happen? These two atomic orbital will overlap, and they will overlap means we'll get this shape. The minus, minus and plus plus. So this is bonding molecular orbital. This molecular orbital has been formed from pz. This is atom A and this is atom B. So this will be called as sigma pz molecular orbital. Then bonding molecular orbital. Now the second possibility is that subtraction. In subtraction, what will happen? This is a minus, so the sign will change, and ultimately sign change means this is crest and this is strip. Plus minus stand for the crest and trough. Here the crest. Addition, that is a crest. But if it is a minus, then it will be minus sign. So plus, and this will become minus due to this minus sign. So crest and trough overlapping. Crest and trough overlapping means the subtraction, or I can say repulsion, will take place. Repulsion means anti-bonding. The energy will goes on increasing. So in this case, what happened? Whole energy get concentrated on the overlapping side. That's why this gets smaller, this size and this size. But in case of repulsion, what will happen? These two orbitals are overlapping, so the orbitals will move away from each other. So all the energy get concentrated on toward the opposite side, and we get shape of the orbital something like this. So this is minus, plus, due to the sign minus change because we are subtracting, and then plus, and it will be called as sigma pz, but since it's anti-bonding, so star or strict. So these are the two possibilities when the pz orbitals overlap or combine together. Now what will happen if the px and py will combine? Both are undergoing the same lateral overlapping, so the representation for both is same only. So let's see for the px and py, which are undergoing lateral overlapping. So these two undergoes lateral overlapping. Plus, minus. Psi A plus B, that is the addition of these two orbitals, and here we have subtraction of the orbitals, that is anti-bonding. Either we can call it as a px or py. This is also px or py. This is from A atom and this is from B atom. If the addition undergoes, addition means the overlapping is taking place, and if the overlapping is taking place, then a nodes will form something like this. Both overlap. This is the upper region and this is the lower region. Upper region plus and this is lower region minus. So bonding molecular orbital, the name will be, during the overlapping, they undergoes lateral overlapping, and lateral overlapping, that means I can say it is a pi pz orbital, px, or I can say pi py, depending on this is px or py. Okay, now what will happen in this case? Subtraction, that means here this will become minus and this will become plus. So ultimately crest, trough, crest. So repulsion will be there. Means two orbitals will repel each other. and this will form. So plus, minus, minus, and this is plus, and this is pi star px, or I can say pi star py, depending on whether it is a px orbital or py orbital. So as I said, here we are going to consider the molecule which contain s and p orbitals. So whenever two s orbitals combines, the molecular orbital which form is called as a sigma s or sigma star s. Sigma s, that is a bonding molecular orbital, sigma bonding molecular orbital, star means sigma anti-bonding molecular orbital having a higher energy, and the repulsion is more. Similarly, if that p is, in case of p, we have three orbitals, that is a px, py, and pz, and as I said, the molecular orbital theory says that the internuclear axis should be considered here as a z axis. So z axis, whenever the pz orbital will combine, it will combine on the axis. That means the bond is going to, the molecular orbital form will be a sigma. So here when two pz orbitals overlap, again addition or subtraction according to LCAO rule. So if they are undergoing addition process, bonding molecular orbital will form, and if they are undergoing subtraction process, antibonding will form, that is again sigma star. The same thing here I can say in the case of this. If px and py undergoes overlapping, if px and py is overlapping, then again addition or subtraction. Addition means bonding takes place, overlaps, and we get a means that upper region and lower region will combine, and you will get a pi because lateral overlapping. And but if it is a subtraction, then we get anti-bonding, that is repulsion takes place, and the energy goes on increasing.